question 1. If you look back at your properties 5 and 6, that's how I would start this one. 5 and 6, we talked about if you have an exponent on something that you're taking the log of, you can bring that exponent down out front. So that's what I would do here. The 7 is an exponent on something that I'm taking the log of. So you can bring that 7 down and make it a coefficient. This you should be able to evaluate without a calculator because it's asking you 2 to what power gives you 2. So all of that is just 1. And so you end up with 7 times 1, which is 7. Okay, questions 1 through 12. What's another question where it looks like you could use that same power rule to start the question? Okay, I agree. 11. 5 is an exponent on something you're taking the log of. So maybe not 100% of the time, but most of the time you want to bring that down and make it not be an exponent. So we got 5 times log base 4 is 4, and log base 4 should be 1. It's 4 to the first is what gives you 4. So you get 5 times 1, which is why all of that should equal 5. Okay. Okay. There might be another one or two that uses the power rule, but let's move on to a different property. Question number 2. This is one that looks like number 8. And as I said, as long as this number and this number are the same, and it's set up this way, it's got the same structure, then all of this simplifies to just be whatever the argument is. So that's what's going on here. 3 to the power of log base 3 of 8 is just going to be 8. And at least for a couple more classes, just trust me, that's how that works. I'll be happy to show you all that works the way it does after we review some more. Okay, so there's another question on here that uses that same property. Very good. This is 10 to the power of log base 10 of 7. So all of that's going to equal, not hard, not a bunch of steps, but you either know the property or you don't. Without knowing the property, you pretty much step it to the end. Okay, I'm skipping a few of these intentionally. I'll have you go back and try them. I'm trying not to repeat too much of the same property. Number 5 here is exactly the same as question number 2, or property number 2 on this sheet. This is one of those I said you don't really need to memorize that because it's natural log, just means log base E, and even though E is a messy decimal of 2.718 ... you should still know what power of E gives you 1, and that would be 2. Because anything to the 0 power gives you 1. So regardless of the base, if the argument is 1, it will equal 0. Do you see that one more time? Number what? Number 8. This is asking 10 to what power gives you 1, and that would be 0. Because anything to the 0 power gives you 1. Very similar questions. Do that one. Do that one. Okay, let's look at number 4. It has a second part too. 5 times the natural log of E means log base E of E. So E to what power gives you E? Multiply that by 5, and you've got your answer. Anytime the base and the argument are the same, it equals 1. Okay, there's another question that applies that same property. Okay, that's true. That's not really the one I was thinking of, but yes. This would be -2 times 1. As long as you understand why that's 1, and it's an easy question. I think the rest of the first 12 have some repeats in the properties. One of them you can be a little more creative on. But try 3, 6, 7, and 10. Make yourself to an answer and see what you think it would be. This should be without a calculator too. Therefore, you don't just type it in the calculator. It doesn't really quiz you on knowing the properties. Okay, so which one do you think is the hardest of those four? 7? Okay, agreed. There's a couple different approaches to it. Let's get that one for last. Number 3. I would apply the power rule and bring x down. Just know why you can do that so that you do that at the correct time. And then x times natural log of e would be x times 1. The answer to number 3 should be x. Number 6, this matches up like question 2. The number, and then its exponent is log of this base is the same number of something. So it's just going to equal that something. These are the same thing. E, base E, 3, base 3. Okay, and question 10. I kind of thought this one looked like number 4, except that you don't have multiply by 5. 10 to the first is what gives you 10. Every time the base and the argument are the same, it will be 1. Okay, question number 7 has 2 different ways of solving this. We are going to review, not today, but expanding and condensing logarithms. That's an important property of logarithms. So if you remember how to expand logarithms, you can do that, and it splits it up into 2 pieces that are pretty easy to evaluate. What else do you think that works? Any guesses on what you think the final answer is going to be? That's correct. -2 is correct. So, to me, this is kind of an exponent trick. Almost always you have a negative exponent. You move it to the other side of the fraction to make it a positive exponent. But, technically, I can move this e to the positive 2 from the denominator to e to the negative 2 in the numerator. So, if you think to try that, now you can apply the power rule, and the negative 2 can come out front, and you get -2 times 1. This is why -2 is the answer. So temporarily, if you remember expanding logarithms already without us reviewing that yet, look that route, and if not, you need to think of the exponent of it. Okay, so one of the most important skills is solving equations, and you're going to just look at some pretty basic ones today, but eventually before your test we will get to more difficult ones. Test will probably have a couple though that are along these lines. So question 13, how could we go about solving that? How can you simplify that stuff? Okay, so just evaluate that, and you're left with something that's easy to solve. Everybody okay with that one? Read see what this. So instead of 14, what could we evaluate in there? How could we simplify that? Okay, so one of the properties, all of this just comes out to be 8. And 2 to what power gives you 8? Okay, so the natural log of this stuff is supposed to equal natural log of that stuff. So this part of the whole sides is already equal. So it'll be the same thing as long as this equals. So set the arguments equal to each other. And you've got your answer. And I put a by this stuff because we do have to put one more thought into that. Same thing here. Log base 2 of this stuff would equal log base 2 of that stuff as long as the steps are equal. So figure out where does 3x equal a half. Where does 3x equal 6? That's easy to mess up that arithmetic. Let's come back to 17 this time. So I guess we can make an equation out of this, but I think we don't need to in this one. Just basically, log base 10 of 2 times x is supposed to equal log base 10 of 6. So what does that make x? Right. If you put 3 in for x, you get log of 6 equals log of 6. So operators not even really needed there. Okay. After this part by this one, I thought we would see another one of these here. But one thing that you need to consider, you need to add this to your notes. Because of how logarithms are computed, and because of its domain, you can never take the log of 0 or any negative. It's not possible to take the log of 0, and it's not possible to take the log of a negative. Now, that kind of makes sense if it was phrased that way to you. On Worksheet the other day, they had a question that went like this, and they were asking themselves 8 to what power gives them 0, and every suggestion that they had, we actually applied that as an exponent. They saw that it didn't give 0. And that's not possible because you can't take the log of 0. Visually, we see that and talk about that all the time. Here's a logarithm graph. It only approaches 0, it never actually equals 0. And the x values are never negative. You can only take the log of positive numbers. That's why it only exists like that. Likewise, that's exactly what domain is referring to. Domain means what x values can you plug in. You can plug in values bigger than 0. So, this had said negative 1, regardless of what the answer said, you would not be able to keep that. If you plug in negative 1 here, you can't take the natural log of negative 2. You can't take the log of any negative 2. Okay, so what about this one? 8 to what power gives you 16? That's going to be 2, right? So that would be, I made multiple choice question. Why do you think I would make that one of the choices? Because of multiplication. That's a big temptation to multiply. So we'll deal with that. So I was saying 8 to what power gives us 16? Well, we can estimate it 8 to the first would give us 8. That's not enough. 8 squared would be 64, and that's way too much. So, with very little effort, you see that the answer has to be between 1 and 2. Okay. And 16 is closer to 8 than it is to 64. So our answer is probably closer to 1 than it is to 2, although exponentials sometimes that's kind of tricky. So here's how I would work this question if I were you. I think this is a two-step question. Most people see it better if you see it in two steps. Now, I think it's still good to think of this, to know that your final answer needs to be between 1 and 2. That also tells you it's going to be a fraction. If I could somehow raise 8 to something, and then I can think of that here, and then raise that to something and get to 16. That's sometimes easier. And the something I would want to raise it to is I really would like to change this to a 2, because if I can change this to a 2, 2 to what power gives you 16? Okay, so if I can somehow change an 8 to a 2, my second step can just be raising it to a 4. Also, anything I can raise 8 to get 2, and third, there we go. So remember, an exponent of a half is like a square root, so an exponent of a third is like a cube root. The cube root of 8 is 2, and then 2 to the 4th is 16. So you want to do both of these operations. So 4/3 is the answer there. There's 4/3 between 1 and 2. Closer to 1 than it is to 2. Just like 16 is closer to 8 than it is to 64. But I really think, you don't have to, of course, but most people do better if they try to split that up into 2 steps like that. Okay, so that's reviewing the properties, some sample questions, reviewing some solving equations, some basic ones, and then all of this has to do with the graph, the other thing that we want you to be able to do. So, what is the inverse of 2 to the x? Log base 2 to the x. Those are inverses of each other. So, if you know what 2 to the x looks like, 4, you plug in a handful of points to figure out what it should be. That should assist you in figuring out what this graph looks like, because 2 to the x and log base 2 to the x are inverses. So if 0, 1 is a point on 2 to the x, 1, 0 is a point on log base 2 to the x. 2, 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 3, 8 becomes 8, 3. So, can you memorize that? Of course. A lot of times, logarithmic functions, you can think of it as a parent function. They all basically look like this. And then finally, you could say, all right, well, that's just the parent function. This function also has a transformation left for it. So, I actually want to look at this is where it helps to have some specific things. That's the graph that I actually care about. So that's worst case. Worst case is you memorize this, which you need to know that anyway. You graph 2 to the x, you switch x and y to get log base 2 to the x, and then you apply any and all transformations. Okay, now that you've got this graph in front of you, I'd like you to try to fill in these blanks. Assuming that you can get the graph right, see if you know what all those things are asking for. Depending on how detailed your graph is, certainly not. But a general logarithmic graph has a domain of 0 to infinity. So shifting this left forward is also going to shift the domain left forward. It's all the y values, but shifting it left doesn't change the fact that it still is all the y values. Range is all the range. Logarithms, by default, have a vertical asymptote of x equals 0. But if you shift the graph left forward, vertical asymptote is going to shift left forward too. If your graph is too much of a sketch, you might think it's -3 or -5. You might be a little bit off there. You see, by default, the parent function is at 1. So if you shift it left forward, it's going to be a 3. Let's put a question mark on this one. Because sometimes it's easy to see, but it depends on what the graph is. So on this graph, this point shifted left forward tells me it is at 2. But sometimes it's not easy to see that. So kind of a backup plan would be plug in 0 for x, because y-intercepts always have an x value of 0. And if you do that, you should be left with something that you can evaluate. You can see that gives you 2 also. And in x is 4, it looks like it's at 3. But again, that could be just me doing the sketch too quickly. So also plug it in. You see that y is log base 2 of 8. And 2 to the 3rd power is what gives you 8. So that's consistent with what the graph looks like. It could just be really close, so we're trying not to assume that.